Hey everyone, this is Andrew. Welcome back to the channel and welcome back to the organic chemistry series. In this video, I will be discussing how to identify functional groups in organic compounds. Okay, so in this video, I just want to run through some functional groups and how to identify them in organic compounds whenever you come across them in organic chemistry. Functional groups are the cornerstone of organic chemistry, and so in order to organic chemistry, you must know what the functional groups look like and how to identify them in organic compounds. So to start, take a look at this one. What we have here is a carbon bonded to a bromine. A bromine atom is a halogen. A halogen is a group 17 atom on the periodic table. This one gets the name alkyl halide. It sounds just like halogen, it's just halide, alkyl halide. Okay, so moving on to the second one. What do we have here? If you want to pause the video and do it, go ahead, but I'm just going to move on. What we have here is an NH2 group. The NH2 groups, when bonded in the middle of a carbon chain, get the name amine. That is an amine functional group. So how about this example? What do we have here? Well, we see that we have what looks like an amine, an NH2 group, but what's this? This is called a carbonyl group. Carbonyl is a broad term for a carbon double bonded to an oxygen. It could be at the end of a molecule, it could be in the middle. It still gets the term carbonyl. However, in this case, when these two are next to each other, the name of this is an amide functional group. An amide functional group is when you have an amine bonded next to a carbonyl group. How about this example? What do we have here? So we see we have another carbonyl. However, there is a hydroxyl. That's what this is, an O bonded to an H at the end. Now, when this carbon is bonded to an oxygen with a hydrogen attached, so what we have here is a carbonyl with a hydroxyl. So what this gets called, this is a carboxylic acid. Carboxylic acids are extremely widely known in organic chemistry. And in this case, if you want to take this a step further, what we have here is a benzene ring. And so this can get the name benzoic acid. So how about this example? We have another carbonyl group. In this case, it's bonded next to a hydrogen. So what does this get called? This is an aldehyde. Okay, so we're going to take this a step further. Now we have more than one functional group to identify. This next example looks a little more complex. Let's start on this left side. This right here, a carbonyl by itself in the middle of a chain, is simply a ketone. A carbonyl on the internal side of a carbon chain is a ketone. Now how about this mess? What's this? We have a sulfur atom bonded to a carbonyl terminally. So we have a CH3 at the end. So what does this get called? This gets the name thioester. In this compound, we have a ketone and a thioester. So how about this one? It's pretty simplistic. It's just a sulfur atom in the middle of a carbon chain. This just gets the name sulfide. That there is a sulfide functional group. So what do we have here? So when you take a sulfide and bond it to an oxygen atom, what do you get? Well, for starters, we see that the sulfur has a partial positive and oxygen is a partial negative. This is because the sulfur atom is bigger. The oxygen atom is smaller than the sulfur atom. Therefore, the oxygen atom holds its electrons closer, so it gets more electronegative than the sulfur atom. That's just a side note. However, this gets termed a sulfoxide group. At this point, you're probably wondering what's up with all the carbonyl groups. However, there is a method to it. This is simply called an acid chloride. So when we take a look at this next example, we see we got a sulfur atom bonded to a hydrogen atom. This simply gets the name thiol. Alright, so next example. What do you have here? Fun fact, this compound is actually called vanillin. If you can take a guess, vanillin, this is actually the compound that gives vanilla its awesome scent. So, looking at its functional groups, what do we have? Here, we have an aldehyde. What's this next one? We have an oxygen bonded to a terminal CH3 group. This gets termed ether. That is an ether functional group. Now, let's look at this last functional group on this compound. What is this? An oxygen bonded to a hydrogen. This is a hydroxyl functional group, also known as an alcohol. Okay, so let's look at one final example. This one looks very similar to the one we discussed previously, the thioester. However, instead of a sulfur atom, it's an oxygen atom. This is simply called an ester. Thank you for watching. I hope you found that interesting and insightful. Functional groups, like I said, are the cornerstone of organic chemistry. So as we move forward with alkene reactions, alkyne reactions, reactions of cyclic compounds, knowing the functional groups is key. So if you have to watch this video more than once, go ahead. The functional groups, there should be a table in every single organic chemistry textbook that you buy. Run through them, just practice them over and over, and you'll get used to them, you'll remember them. Thank you for watching. I hope this was helpful, and I'll see you in the next one.